Knowing what to do for the rest of your life is hard. Everyone has that time where they're looking up, down, or maybe even climbing Mount Everest for something that interests them or a field that they'd be willing to study about and work in. So, if you're currently going through that, may I interest you in some medical physics? Medical physics is a branch of physics that uses the fundamental rules that govern how the universe works to effect cures for the various diseases in the human body in the language of math. That's a mouthful, but basically, physics adds purpose to math and science, and in medical physics, that purpose is to help people. Now, you have a choice to make, clinical versus developmental. Both roles are fun, I promise. Pinky promise. So let's dive right into it. For clinical medical physics, physicists work in diagnosing, imaging, and caring for specific patients. One thing they do is come up with the treatment plans for patients, as in, how much radiation do we give to these parts, and how do we use this machine on this patient. Other activities include making sure the imaging equipment is operating well, checking the general quality of other machines, and controlling radiation hazard. So basically, they're that one friend who always has band-aids with them, or always sends a text to check up on you. For research/developmental physics, medical physicists are involved in finding new, more precise techniques, or developing new technology. For example, for cancer, many research projects are in building more effective machines. One research area is flash radiation therapy, where delivering dose super quickly spares healthy tissue while delivering the same effect to the tumor. Now, the research done isn't like the research or experiments you do in high school, where you're put into a group and one kid is talking to another group, one kid somehow broke what you need to use, and another kid is just sitting with you, wondering how you guys are going to complete the project. Research is based on coming up with an idea to improve the process of helping others, and then trying to make that idea become a reality. It's like a light bulb moment that you have, and then tinkering away with your friends helping you. There's also an area in medical physics that's involved with teaching. So, if you're interested in helping others through training future medical physicists, that role might be for you. Now, what do you need to do to become a medical physicist? Well, for the clinical route, you should receive a master's or PhD in medical physics, or some related topic. Then you need clinical training through either a postdoctorate program or a residency in a hospital, of which both usually last 1 or 2 years. You need to receive a certification in order to work in the hospital, as you are working with and treating real people. They don't want someone who will trip over a table during a patient's treatment or someone who will mess up with the imaging. For the research route, most people usually have the same credentials. However, this route is more open in that you don't necessarily need the clinical training or any certification. Now I'll be having various medical physicists describe how they became interested in the field.
I'm in this field because it saves lives of cancer patients. And because my mom was someone who actually was diagnosed with breast cancer, I decided to go into this field and combine my knowledge of physics into medicine so that I could help to save these lives.
I got an undergraduate degree in physics. It was very, physics is pretty cool. And my first job actually was a summer job at a place called Memorial Sloan Kettering Cancer Center, which is one of the 2 or 3 largest cancer centers in the world, and it's in New York City. And so I did research there, back in more than 35 years ago. So, and so I have had many members of my family have had cancer, and sort of been a personal thing for me. So I've spent most of my time in clinical medical physics. So a favorite part of my job is putting together sort of the multidisciplinary medicine part of things. So getting medical physics, surgeons, radiation oncologists, medical oncologists all together sort of in the same room, in the same intellectual room to treat the patient together, as opposed to having what typically happens is individual silos. So trying to get people to kind of talk to one another and talk cross disciplines. So essentially translating from one discipline to the other, so that we're all speaking on ultimately we're trying to take care of the patient and doing the best for the patient.
For me, it was, I started in laser physics originally, and I think what I was missing in that was I couldn't explain what I was doing to my grandmother. It was so esoteric that it was really hard for me to have conversations with people that were important in my life but didn't understand physics. No one in my family is a scientist or anything like that. And I loved medical physics because it was so clear that it had immediate benefit to society, and I could explain why I was doing it, what it was for. So I just loved the context and knowing that there was a meaning behind my work.
So I was initially involved in physics and math in undergrad, and I was kind of disillusioned by the fact that my work might not help people in general. So once I found out that medical physics was a profession, I was very interested and haven't looked back since. I don't necessarily want to work with patients, but I do want to, know that my work will end up helping people in the short term.
As you grow up, you enjoy that kind of stuff. There's always someone that's sitting with a ruler or a spanner or something, or working in something, in the backyard, in the shed or something like that. It's there are a lot of people that like that. I love sport, and the irony with sport is that there's a lot of physics in sport, and you don't always think about it. People always think about physics being just mathematics and calculations, but being involved in sport, and where I was from, cricket, so understanding how to hit the ball and what angles work and all that kind of stuff, you learn a lot. But once we actually got trained a little bit at school about how to use physics to make it better for us as sportsmen. And when we learned about how to hold the cricket bat and what angles to use and how fast to swing, these are all real basic physics things. So we were learning physics without actually realizing we were doing that, but we were getting better at sport at the same time as well. So it's a good way.
The main takeaway from this video is that medical physics is a way that people who like math and science can help others. You can add purpose to the little math problems that you do now and then. You don't need to figure everything out now, but I hope you keep this option in the back of your mind. We'll be waiting for you once you make your decision, and while we wait, we'll try not to create a machine that can take over the world, even though that would be really interesting if we're being honest.